Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're going to be looking at Unit 7 on quadratic equations, Lesson 22, Rewriting quadratic expressions in vertex form. The learning goal in this video is to see what else completing the square can help us do. We have 3 learning targets in this lesson. When we're done with the practice problems, we'll come back and review these and ensure you've learned everything you need to be prepared before moving on to the next lesson. Learning target number 1 says I can identify the vertex of the graph of a quadratic function when the expression that defines it is written in vertex form. Learning target number 2 says I know the meaning of the term vertex form and can recognize examples of quadratic expressions written in this form. And learning target number 3 says when given a quadratic expression in standard form, I can rewrite it in vertex form. We have one glossary term in this lesson, and that is vertex form of a quadratic expression. The vertex form of a quadratic expression in x is a times the quantity of x minus h squared plus k, where a, h, and k are constants and a is not 0. Hopefully, for the most part, this lesson will be a review if you watched our videos earlier in Unit 6 about vertex form quadratic equations. Now we can begin on the practice problems for Unit 7, Lesson 22. The following quadratic expressions all define the same function. So first, they give us factored form, then they give us standard form, and finally they give us vertex form. Now, if you look at all of your answers, the answers are referring to the y-intercept, the vertex, and the x-intercepts. So you need to remember back to Unit 6 and what each form gives us. When we have the factored form, we use that to find the x-intercepts. When we have the standard form, we use that to find the y-intercepts. And when we have the vertex form, we use that to find the vertex. So if we look at A and if we look at F, those two are referencing the y-intercept. The y-intercept comes from the standard form. So we have x squared plus 8x plus 15. In a standard form expression or equation, it is the c term that tells us what the y-intercept is. So here we can see that the c term is positive 15. That means the y-intercept is positive 15. So choice F is correct, and choice A is wrong. Next, we can look at B and G. B and G are both referencing the vertex. That means we're going to use the vertex form, which is the quantity of x plus 4 squared minus 1. Now, if you remember vertex form, it is x minus h plus k. And the vertex is hk. So in this case, if it's x minus h, but we have x plus 4, then h must be negative 4. Because x minus negative 4 would give us x plus 4. Then the y term is the k, and it is plus k. That means k must be negative 1 so that we end up with a minus 1 outside the parentheses. This means B is correct. The vertex is negative 4, negative 1, and G is wrong. And finally, we have C, D, and E, all referencing the x-intercepts. X, or C, and D both say there are 2 x-intercepts, and E says there are only 1. To find the x-intercepts, we use the factored form, and we set each factor equal to 0. So we have x plus 5 equals 0, because the first factor is x plus 5. Then we have x plus 3 equals 0. So we're going to have 2 different answers, so we know already E must be wrong. Now we need to solve for x. In the first one, we need to get rid of the plus 5. The opposite of plus 5 is minus 5. So we're going to subtract it from both sides. And the first answer is x equals negative 5. So we can already see that D is going to be wrong. Another way that we could have known that D and E were going to be wrong is that the x's are all 0, but the y's all have numbers. These are going to be y-intercepts, not x-intercepts. When we solve the second one, we need to get rid of this plus 3. The opposite of plus 3 is minus 3. So we're going to do it to both sides to keep it equal. And we get x equals negative 3. And we can see choice C matches this answer. So the correct statements in this practice problem are B, the vertex is -4, -1. C, the x-intercepts are -5, 0, and -3, 0. And F, the y-intercept is 0, 15. If you have any questions about this, please leave a comment below, and I'll get back to you with any help that I can offer. Practice problem number 2. The following expressions all define the same quadratic function. So again, they gave us a factored form, which is used to find the x-intercepts. They gave us a standard form, which is used to find the y-intercept. And we have a vertex form, which is used to find the vertex. Number 1 wants to know what is the y-intercept of the graph of the function. Well, the y-intercept is the c term in the standard form. That means the y-intercept is going to be 0, -24. And we could plot that right about here where I put this blue dot. Number 2, what are the x-intercepts of the graph? Well, for that, we use the factored form. First, we set x minus 4 equal to 0. The opposite of subtracting 4 is adding 4. So we add 4 to both sides to keep it equal, and we have x equals 4, which means the first x-intercept is at 4, 0. And we can plot that right here on the right side where I put this orange dot. Then we take the second factor, which is x plus 6, and we set it equal to 0. The opposite of plus 6 is minus 6, so we subtract it from both sides to keep it equal. This gives us x equals -6, which means the other x-intercept is at -6, 0. And that would be over here on the left side where I put this orange dot. And number 3, what is the vertex of the graph? Well, we use the vertex form for that. And vertex form is x minus h squared plus k, where the h is the x-coordinate and the k is the y-coordinate. So in this case, if it's x minus h, then h must be -1. Because x minus -1 would become x plus 1. And the k would need to be -25 because we have plus k, so -25 would make it -25. So now we can go left to where -1 would be, and down to where -25 would be. And our vertex is going to be down here at the bottom where I put this green dot. And number 4 wants us to sketch a graph of the function without graphing technology. Make sure the x-intercepts, the y-intercept, and the vertex are plotted accurately. And that's what we just did in numbers 1, 2, and 3. So now we simply need to draw the parabola that goes through these points and just continue it upwards. So this would be an approximate sketch of what the graph would look like with the x-intercepts, the y-intercept, and the vertex plotted accurately. If you have any questions about this practice problem, please leave a comment below and I'll get back to you with any help that I can offer. Practice problem number 3. Here is one way an expression in standard form is rewritten into vertex form. They show us the steps on the left with the step numbers on the right. Number 1, in step 1, where did the number -7 divided by 2 come from? Or -7/2. So to go from the original expression to step 1, this -7/2 is the term 2. And we find term 2 by taking b and dividing it by 2. So I'm going to put that right here. So dividing the b term by 2. Number 2. In step 1, y was -7/2 squared, added, and then subtracted. So it was added as the new c term. It was subtracted so that we weren't changing the value of the expression. Number 3. What happened in step 2? Well, the first thing that happened, and because of space, I'll actually write it up here next to step 2. These first 3 terms are now standard form. That standard form was rewritten into factored form as a perfect square. So the first 3 terms were rewritten as a perfect square. Also, they squared the negative 7/2 term. So that's what happened in step 2. Number 4. What happened in step 3? The only thing that changed is this 6 has been rewritten as 24/4. And that is so that they can do the subtraction with the minus 49/4. They needed to make sure the denominators matched on the bottom. And number 5, what does the last expression tell us about the graph of a function defined by this expression? Notice step 4 is vertex form. This tells us the vertex, because it's x minus h, then h must be 7/2. And then since it's plus k, k must be negative 25/4. So now we know where the vertex is. If you have any questions about anything that was covered in this process of rewriting a standard form expression into a vertex expression so that you can identify the vertex, please leave a comment below and I will answer back with any help that I can offer. Practice problem number 4 is going to be the last practice problem in this lesson. Here, they want us to rewrite each quadratic expression in vertex form. For number 1, remember to ask yourself, is my ax squared term a perfect square? And it is. Then ask yourself, is my c term a perfect square? And in this case, it is. And then thirdly, ask yourself, is my bx term 2 times the first term times the second term? And in this case, that's actually true. They have given us a standard form perfect square. So we can actually take what they've given us, x squared plus 12x plus 36, and we can actually rewrite this as x plus 6 squared. And if you want to double check, x times x gives us x squared. X times 6 is 6x. 6 times x is 6x. So when you add them together, you get 12x. And then 6 times 6 is 36. So now that we've written it as a perfect square, you can say that that is also vertex form, because we would have x minus h, where h is negative 6, plus k, where k is 0. So in this instance, the vertex and the x-intercept are the same point. So this is the vertex form that they wanted us to rewrite it into. Let's look at number 2. Let's ask ourselves, is the ax squared term a perfect square? In this case, it is. It's x squared. Then ask ourselves, is the c term a perfect square? And it's not. 21 is not a perfect square. So we're going to have to use completing the square. We have x squared plus 10x. Let's leave a gap. And then plus 21. The first thing we're going to do is take the b term, which is 10, and divide it by 2. This is going to give us 5. Now we can take that 5 and we can square it, and that gives us 25. So we're going to add 25 as the new c term, but since we added 25, we need to make sure we subtract 25 so that it doesn't really change the value of the expression. Now, if we look at the first 3 terms, this is our new standard form, and we're going to rewrite that as being x plus 5 squared. Then we look at our last 2 terms, and we have 21 minus 25, and that gives us minus 4. This is now vertex form. And based off of this, since it's x minus h, we know h must be negative 5. And then outside parentheses, it's plus k, so k must be negative 4. So this would be the coordinate of the vertex. And then number 3, ask ourselves, is ax squared a perfect square? And it's not, because 2 is not a perfect square. So we're going to have to use completing the square. So we're going to have 2x squared minus 20x, leave a space, plus 32. Now, I'm going to factor out a 2 from this 2x squared minus 20x. So that's going to give us 2 times x squared minus 10x plus 32. Now we would take the b term, which is negative 10, and we would divide that by 2. And that gives us negative 5. Now we take that negative 5 and we square it, and that gives us 25. So we're going to add that in as the new c term. But here's where you need to be very careful, because since I factored this 2 out, I'm not really adding 25, I'm adding 2 times 25, which means I'm adding 50. And if I add 50, I need to subtract 50 so that I'm not really changing the value of this overall expression. Now that I've done that, I can take the 2 and bring it down, and I'm going to take this standard form that's inside the parentheses, and I'm going to rewrite that as x minus 5 squared. Then I have 32 minus 50, which is negative 18, and this is my vertex form. Now I know, since vertex form is a times x minus h, my h value must be 5, and then outside parentheses I have plus k. My k value must be negative 18. That's where my vertex would be. If you have any questions about how to solve this practice problem or any of the practice problems from this lesson, please leave a comment below and I'll get back to you with any help that I can offer. Now, before we finish the video, let's go back, review the learning targets, and ensure you know everything you need to be prepared moving forward into the next lesson. Now let's review the learning targets for lesson 22. Number 1 says that you can identify the vertex of the graph of a quadratic function when the expression that defines it is written in vertex form. So this goes back to understanding that vertex form is a times x minus h squared plus k. And the h represents the x-coordinate of your vertex, and k represents the y-coordinate of your vertex. Learning target number 2 says that you know the meaning of the term vertex form and that you can recognize examples of quadratic expressions written in this form. So again, this goes back to the format of a times x minus h squared plus k, where h represents the x-coordinate of your vertex and k represents the y-coordinate of your vertex. And learning target number 3, when given a quadratic expression in standard form, you can rewrite it in vertex form. This is what we were doing in the practice problems. We take the first 2 terms of the standard form, we use them to complete the square and find the c term that will allow us to complete the square. But when we add that c term, we also need to subtract that c term so that we're not really changing the value of the expression. We then take those first three terms where we've completed the square, and we rewrite that standard form perfect square into a factored form perfect square. Then we can take those last two terms and combine them, and what we end up with is the vertex form of the expression. I hope all of this has made sense to you. If you still have any questions from this lesson, please leave a comment below, and I'll get back to you with any help that I can offer. In the bottom left of the screen, you should see a video that YouTube believes you'll find helpful, and in the bottom right corner of the screen, you should see a subscription button for the channel. Please give it a subscribe, please give the video a thumbs up, and I look forward to seeing you in the next lesson.